multiples, factors, and prime factorization. These three terms are very important when dealing with the multiplication and division of whole numbers without any remainder whatsoever. Product is a word that I'm going to use a lot in this video. And in case you don't remember or know, product is just the result of the multiplication between two or more numbers. For example, 2 times 3 is 6. Therefore, 6 is the product of 2 and 3. Alright, stay tuned as these terms are going to be explained in detail. A multiple is a number that can be divided by another certain number without a remainder. This is a 12 by 12 multiplication table which shows the products of numbers 0 to 12. And the numbers in red are called perfect squares or square numbers, which is the product of a number multiplied by itself. Whole numbers are multiples of 1, while multiples of 2 are called even numbers. Now, if you take the even numbers out of the whole numbers here, you will be left with odd numbers, which is simply any number that cannot be divided by 2. The multiples of 12 and 9, where the red circle represents the multiples of 12 and the green circle represents the multiples of 9. Now these numbers in between are the common multiples of 12 and 9. Common multiples are simply multiples that two or more numbers have in common. Now the first number to appear here is called the lowest common multiple, or commonly termed as LCM. As you can see down here, the numbers in yellow are the common multiples of both 12 and 9. And the first number to appear here, which is 36, is the lowest common multiple of 12 and 9. Now let's go on and take some more examples of LCM. Now there are two main methods for finding the LCM of two or more numbers. The first method is what we are going to use for these 4 examples. So example A, the LCM of 5 and 27 is 135, since it is the first number to appear in the list of multiples of both 5 and 27. Example B, the lowest common multiple of 13 and 39 is 39. Example C, the LCM of 12 and 15 is 60, since it is the first number to appear. Now to find the LCM of 12, 15 and 9. The LCM of 12 and 15 is what we already got here, which is 60. So we can just list out the multiples of 60 and the multiples of 9 until we get a common multiple. The first common multiple is 180. Therefore, 180 is the answer. A factor is an integer that can divide another certain number without a remainder. Any number with more than 3 factors is a composite number. Now, while square numbers are products of a number multiplied by itself, square-free numbers are not square numbers. The factors of these 3 numbers are gotten by the same process. First of all, 1 and the number itself, which is 24, are written down. Now, move on to number 2. Can 24 be divided by 2? Yes. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. But 24 cannot be divided by 5. Therefore, these are the only factors of 24. As for 27, 1 and the number itself are already there. 27 cannot be divided by 2, but it can be divided by 3, and this gives us 9. 27 cannot be divided by 4, 5, 6, 7, or 8. Therefore, 1, 3, 9, and 27 are the only factors of 27. Through this same process, you can get these factors of 32. As for the square numbers, let's take 36 for example. 1 and 36 are already there. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 cannot be divided by 5, but 36 divided by 6 is 6 itself. Therefore, 6 is the square root of 36. The square root of a number is the number that is multiplied by itself to give that number. Same thing for 49 and 100. 7 times 7 is 49, 6 times 6 is 36, and 10 times 10 is 100. Now, square-free numbers have even number of factors, while square numbers have odd number of factors. Prime numbers are numbers that have only two factors, namely 1 and the number itself. So what you see before you now are prime numbers between 1 and 500. The only common factor between two or more prime numbers is the number 1. Now, just like the lowest common multiple, there's also the highest common factor, which is the biggest factor that two or more numbers have in common. Example A. The highest common factor of 24 and 27 is 3, since this is the biggest number. In fact, it is the only factor that 24 and 27 have in common. Example B. The HCF of 175 is 25. Example C. The HCF of 70 and 80 is 14. This is the biggest number, the biggest factor that 70 and 84 have in common. Now, example D is the HCF of 70, 84, and 135. Since we already know the HCF of 70 and 84, which is 14, we can just list out the factors of 14, 1, 2, 7, and 14, as well as those of 135. The highest common factor, or the only factor that 14 and 135 have in common, is 1. Therefore, 1 is the highest common factor of 70, 84, and 135. This is yet another Venn diagram, but this time representing the factors of 84, 135, and 70, just like in example D. 3 and 1 are the common factors of 84 and 135. 1 and 5 are the common factors of 135 and 70. Finally, 1, 2, 7, and 14 are the common factors of 84 and 70. And this means 1 is the only common factor of all three numbers. Therefore, also leaving it as the highest common factor. Relationship between multiples and factors. Let us take 25 and 50 as our example. 25 is a factor of 50. This means that 50 is a multiple of 25. These are the only whole numbers that can divide 50 without any remainder. All factors of 50 have a common multiple of 50. Now 1 times 50 is 50. 50 times 1 is 50. This is why 1 has 50 multiples, while 50 has 1 multiple. 2 times 25 is 50. 25 times 2 is also 50. This is why the 25th multiple of 2 is 50, and the second multiple of 25 is 50. 5 times 10 is 50, and 10 times 5 is 50. This is why the 5th multiple of 10 is 50, and the 10th multiple of 5 is 50. The number is a factor of itself as well as a multiple of itself. This is why all numbers have themselves as the first multiple, while they have themselves as the last factors. Therefore, the lowest common multiple between a number and its multiple is the multiple itself. As you can see, this is the first number that they have in common. The first multiple that they have in common, making it the lowest common multiple. Same with 12 and 36. 36 being their lowest common multiple. In the same way, the highest common factor between a number and its factor is the factor itself. Therefore, the highest common factor between 25 and 50 is 25, while that of 12 and 36 is 12. As you can see, they are basically opposites. Prime factorization is the process of representing composite numbers as a product of prime factors. A prime factor is a factor that is a prime number. Prime factorization might sound intimidating or complex, but trust me, it is really easy. All you have to do is to divide a certain composite number by prime numbers until the number can't be broken down any further, starting from the first prime number and then going upwards until the process is complete. Let's take our first example, 14,420 divided by 2 will give you 7,210. Divided by 2 again, 3,605. Now this number can't be divided by 2 any longer, so we move on to 3. It also can't be divided by 3, so we move on to 5. 3,605 divided by 5 is 721. This number can't be divided by 5 any longer, so the next prime number is 7, and the answer will be 103. 103 cannot be divided any further because it is also a prime number, as you can see in this list of prime numbers. Therefore, 14,420 equals 2 raised to power 2, since the number 2 appears twice, times 5 times 7 times 103. That is the final answer. Moving on to 36. Divided by 2, you get 18. Divided by 2 again, you get 9. Now divided by 3, and you get 3. 3 is also a prime number, so that is the end of the process. Therefore, 36 equals 2 raised to power 2 times 3 raised to power 2, since 2 appears twice and so does 3. More examples of the prime factorization of composite numbers. Prime factorization also helps in calculating the highest common factor and the lowest common multiple between two or more numbers. Starting from example A, 6 and 30 have 2 and 3 in common. Therefore, the highest common factor equals 2 times 3, which will give you 6. Now, the lowest common multiple equals the product of both numbers divided by their highest common factor. But note that this works for only two numbers and not more than that. Alright, 6 times 30 divided by the highest common factor, 6, will give you 30 as the lowest common multiple. Example B. Both numbers have at least 1 3 and 1 7 in common. Therefore, the highest common factor equals 3 times 7, which will give you 21. As for the lowest common multiple, we are going to use the elimination method. So 105 and 63 have 3 in common. So cancel out the smaller 3. They also have 7 in common. So cancel out one of the 7s. Now, the numbers that are left uncancelled, we will write them out and multiply them to give you the lowest common multiple. Really fun, isn't it? Example C. 135 has 3. 84 has it, but 70 does not have it. It has 5. 84 does not have it, but 70 has it. This means that all three of them have no prime factor in common. Therefore, the highest common factor is automatically 1. I hope that makes sense. As for the lowest common multiple, 135 has 3 raised to the power of 3. So does 84. So we will cancel the smaller 3. 135 has 5. So does 70. So cancel out 5. 84 has 2 squared. So does 70. So cancel out 2. 84 has 7. Cancel out 7 from 70. And now the numbers you are left with, write them out and multiply them to give you the lowest common multiple, which is 3,780. Let's end the video with a word problem using everything that we've learned so far. What is the smallest number that 1 to 10 can each divide without any remainder? Alright, let's list them out with their prime factors. Notice all the prime numbers have only one prime factor, which is themselves, and 1 is a factor of all integers. That is why 1 isn't listed among these. Alright, let's begin. 2 is a factor of 4, 3 is a factor of 6, and 5 is a factor of 10. Therefore, these 3 are automatically out. 4 is a factor of 8, so out
it goes as well. The factors of 6 already exist in other numbers. 2 here is a factor of 8 and 3 is a factor of 9. So goodbye 6. Finally, 10 has 2 as its factor, but 2 already exists in 8. And since 2 raised to the power of 3 is greater than 2, this 2 is cancelled. Therefore, let's write out the remaining factors, which are 5, 9, 8, and 7. Multiply them and you will get 2520. Therefore, the smallest number that can be divided by 1 to 10 each with no remainder is 2520. This is their lowest common multiple. Please feel free to ask me anything that you might not have understood in this video, and I'll be delighted to help you with that.